Hello everyone, how are you? Do you have my voice?
Yes,
Okay, nice. Uh, Actually, you know that the universities has been opened, and then actually we should have our classes face to face. But because of the because the number of the students of this class is so high, I think actually it's including 90 or 84 and 5 students. And as I had experience from the Monday courses that most of the students didn't attend for class as face to face. So today I decided to have this course also as online. However, I'm at university, and actually I went to the conference room, but nobody was there. Uh, Anyway, today class would be as online, but I can discuss about the next sessions because, as I said, this class is including so many students and cooperating about the issue with this number of students will be so difficult, knowing their ideas about type of the classes and so on. Anyway, I want to start the discussion of today class. As you remember, however, after class we can talk about the next sessions classes that would be as online or face to face. Today I want to continue my discussion about the different types of the functions. However, previous session we said that there are in general two types of functions. One of them was standard library function, and the other was user-defined function. We said that standard library functions, when we want to use them, the preprocessor should be added to our codes at the first of our coding. And we know that the preprocessor is including the header file. For example, about printf that we talked about it, we said that the preprocessor, which is including the header file related to printf, is stdu.h. And for example, about sqrt, when we want to use sqrt, which is signing a radical actually in our coding, we use mass.h header file in our preprocessor. Then we said that there is another standard library function, which is delay function, and we didn't talk about it previous session. And we paid to talk about user-defined functions, and we explained them in detail. Today, I want to talk about the delay function. Actually, this function is used to give delay in the code, meaning that it is used to suspend execution of a program for a particular time, and the delay time that's created would be in terms of its input argument, meaning that it would be in terms of millisecond or microseconds. But we said that for using standard library function, at first we need to have the preprocessor, which is including the header file related to them. This is a preprocessor. Why? Because it's starting with number sign and include, and we have a header file related to that. the header file of delay function is delay.h. If you don't write this this preprocessor, then your code will have error or problem. We said that according or in terms of the input arguments, we will have two kinds of delay. Delay in terms of a millisecond, or input argument here is in terms of millisecond. What does it mean? It means that the created delay is in terms of its input argument, and it is in terms of millisecond. And the input argument of this delay is microsecond delay underline US. US means microsecond, meaning that the given delay is in terms of its input argument, which is microseconds. For this type of delay, for example, we can have this code delay underline ms inside parentheses 1000. It means that the time delay is equal 1000 millisecond, and about this one, delay underline us inside the parentheses 1000, it means the time delay is equal 1000 microseconds. Now, after talking about different issues of microcontroller, and also having having a review about C language, I want to start to coding of our microcontroller, AVR microcontroller. We said that we will work with Atmega 16 or 32. But for coding, we need to have input-output configuration at first. Each of input-output ports have a capability of read, write, and modify. Yes, please. Do you have a question, Yusuf?
No, it clicked by itself.
Okay, no problem. Okay, and also each of the ports can be used as input or output independently. We said that about Atmega 16 or Atmega 13 too. How many ports is including in these kinds of AVR microcontroller? Do you have study about them? Do you know? Atmega 16 or 32 is including how many ports? Cooperate with class, please. Please try to have a study. We said that Atmega 16 or 32 is including 4 ports. The name of ports are A, B, C, D. When I was talking about the architecture of Atmega 16 or 32, I explained about them. And each of the ports are including how many pins? 8 pins. Very nice. Thank you, Hamza. And actually the maximum current of each pin is equal 20 milliampere. So we said that there are the Atmega 16 or 32 is including 4 ports. Port A, port B, port C, and port D. Each of the ports are including 8 pins or bits. Actually, there are 3 memory address locations for each of the ports, meaning that for each of port A, B, C, D, we will have 3 register or 3 memory address location. The first one is port data register, which is coded as port X register. Port X here is related to the name of the port that we are using as input or output, or in the rest of the material, I'll talk about each of these registers. The other register is data direction register, which is coded as DDRX. Again, X is related to the port A, B, C, D that we are talking about it. And port input pins register, which is coded as pin X. Again, X here is can be A, B, C, D, related to the port that we are working with that. The port input pins register, the port input pin register, this register, the third one, is read-only register, while these two registers, two first registers, oh really? Okay. After 5 minutes, we continue our discussion, okay? Okay. Okay, hello again. Could you please say something about my voice quality? Okay, nice. Then we can continue. Uh, so, as we said, for each of the ports, port A, B, C, D, we have three memory addresses. One of them is called a port data register, which is read and write. The other is a data direction register, which is also read and write. And the other register, which is port input pin register and is coded as PINX, instead of X, we are using A, B, C, D, is read-only. So the last register is read-only. Then I want to talk about each of the registers one by one, but I'm starting with the second one. Data direction register, which is coded as DDR A, B, C, or D, or DDRX register. Actually, about this register, you see that it is including 8 bits. The index is starting from 0. Then the bit DDA0, DDA1, DDA2 till 2, DDA7. The index is starting from 0. Then when we are talking about the second bit of DDRA register, we should note it by, we should write that bit as DDA1, the second register of DDRA register. So actually, the DDXN bit is in the DDRX register, selects the direction of this pin. If DDXN, meaning that each of these bits is written logic 1, that here is written logic 0, as you see. If they we write logic 1 for each of these pins, that pins is configured as output. Then having one logic 1 value for each of these bits of DDR register, DDRX, it can be A, B, C, D ports, means that the pin which its value is equal 1 is configured as output. Then for configuring a pin of a register related to a port as output, we should write that pin equal to logic 1. For example, we want to make or configure the third pin of port A as output. Then what we can do in DDRA register, for DDA2, we should write logic 1. And also, if DDXN is written logic 0, then that pin is configured as input pin. So, for example, here you see that DDRA register, all of the pins are, for example, suppose that are equal 0. What does it mean? It means that this port totally is configured as input. And if all of the bits are written 1, it means that this port A, is configured as output. But when only one of the bits related to this register of port A is written 1 or 0, then it determines that pin is as input or output related to its logic value. If it is 1, then it is output. If it is 0, then that bit is configured as input. So after talking about data direction register, which was configuring our port bits as input or output, I want to talk about port data register, which is called as port X register. If port Xn is written a logic 1, good listen to me. If port Xn is, you see that port A, for example, we are talking about port A, okay? And the code related to port data register is also written as port X. Here we are talking about port A, then instead of X, we replace A. This is port A register. You see that? I wrote it here. And the previous one was DDR-A register. So if port AXN, for example, port A0, X here is A, and the N here is 0. The index is starting from 0. Port A register is also including how many bits? 8 bits, very good. And the index, because it's starting 0, then the last bit number is equal 7. And first bit number is 0. So if port Xn is written a logic 1, for example, port A0 is written 1. When the pin is configured as an input, how we can configure a pin as an input? I explained about it. I give you the time to write it for me. Or if you want, you can open the microphone and answer the question. By using which register we can configure a pin or a port as an input. Okay, 0 for which register? We said that configuring, very nice, DDR-X register is used for configuring a pin or all of the pins or bits of a register as input or output. So when we are talking here about that, when the pin is configured as an input, meaning that in DDR-X register, that pin value is equal 0. So if port Xn is written a logic 1, when the pin is configured as an input pin, then the pull-up resistor is activated. And to switch the pull-up resistor off, then port Xn has to be written logic 0, or pin has been configured as output pin. So suppose that in DDR-X, for example, when we're talking about port A, DDR-A, bit 0 or first bit is configured as input, meaning that its value is written 0. Then it is configured as input. And in the next step, import AN, for example, in this register, port A0 is written logic 1. This bit is written logic 1. Then it means that the pull-up resistor is activated. And if we want to deactivate the pull-up resistor, we should write its value equal to logic 0, or in DDR register, we change it to 1 or as output. So if port XN is written a logic 1 when the pin is configured as an output, meaning that, for example, when we are talking about first bit of port A, this register is configured as output, meaning that its value is written logic 1. And also in port XN, meaning that port AN, when we are talking about port A, the bit 0 is written logic 1. Now it is configured as output, and the value of port A bit 0 is equal 1. Then the port pin has initial state 1, or it's driven high. And if port XN, or for example here, port A0 is written logic 0, when the pin is configured as an output, as I explained, then the port pin has initial state 0 or is driven low, meaning that it has a voltage of 0, and about this one, when it is logic 1 and it's configured as output, it has the voltage of, for example, 5 volt. The last register that we said that it is only a read-only register, which is called port input pin register, and it is coded as pin X. X can be A, B, C, D. Actually, this register used to read data from port pins. But for reading data from port pins, at first, the port's data direction register should be configured as input. This is done by setting the bits in DDRX to 0. Actually, input-output ports register are bit addressable registers, and in CodeVision, you can use this feature. For example, if you want to get the second bit in the register DDRA, the second bit, because the index is starting from 0, you simply can write DDRA.1. Why 1? Because the index is starting from 0. Am I clear? Okay. Of course, for the ones who listen and try to learn, I'm clear. But for the ones who are not mentally and also physically in the class, everything is ambiguous, and I'm sure that they are really confused by this course. Anyway, I want to have a total discussion about each of these registers. We said that we have port A register, which is including 8 bits. The index is starting from 0, and each of the bits are written as this one: port A0, port A1, port A2, and the register name is port X, or for example, port A, port B, port C, and port D. The other register, which is a data direction register and is coded as DDRA, as you see, DDRA for A port. It's including 8 bits. Also, these two registers, as we talked about it, are read and write registers. And the other register related to each of the ports, for example, port A, the other register is called input pins register, and it is coded as pin A. As you see, this is pin A register. It is including 8 bits, and the name of that is the name of that is, for example, for port A, is pin A, and each of the bits are called as pin A0, pin A1, and the index about all of them are starting from 0. This register, as we talked about it, is read-only, and for reading data from this register, we need to have DDRX register as input, or the bits of DDRA or DDRX as input. So it is the last slide. There are some actually examples, the parts of the codes that I chose and I replaced here for giving the information about each of these registers. For example, suppose that this is our main function inside the curly braces. However, this is what kind of functions? User-defined function, and it is which type? Return type. The return type is int, and its argument is void. The curly braces is opened and enclosed, and inside curly braces we have our codes. So the code is as this one. DDRA is equal 0B. 0B is prefix of what? We use 0B for what? Cooperate with class, please. No. 0B, I explained about it in second or third session. No. When I started to talk about the C language review, the first session of C language review, I talked about it. 0B is used for binary numbers. And for hex numbers, we use 0H. Anyway, so 0B, 1, 1, 1, 1. And there are how many ones here? 8 ones, because DDRX is including how many bits? 8 bits. Very nice. So when we are talking, we are noting it's in terms of binary numbers, then the binary numbers should include 8 numbers. You see that all of these 8 numbers are equal 1. What does it mean? DDRA register is used for configuring the port, for example, here port A, as input or output. If these values, thank you very much, yes, if these values, all of them are 1, as I explained, then it sets all of the pins or bits of port A as output. So port A is equal 0B 10101010. Also, this register is including how many bits? 8 bits. Because we are using binary numbers, then 8 number of logic 0 and 1s are including here. Don't forget semicolon after each code, each statement. Port A, we said that is related to initializing when port is configured or port pins are configured as output. So here 1 means that its initial value is equal 1, or it has a 5 volt high drive one. And 0 means that its initial value is equal 0. However, if DDRA was equal 0B 0000 and port A was equal with this value, what does it mean in this situation? Yes, it is related to pull-up resistor. Thank you, Hamza, for your focusing and cooperating with class. If DDRA register is configured as input, then the values of port A registers means 1 is related to it, meaning that pull-up resistor is activated, and 0 is related to that this pin or bit pull-up resistor is deactivated. Anyway, another code, and again we have user-defined function. It is return type because it is using int before main, and the return type is int type or integer number. Main avoid, curly braces are open and enclosed. DDRA is equal 0B and 8 zeros semicolon, meaning that set all pins of port A of at mega 16 or 32 as input, and X is equal pin A semicolon. Read data on pins. If we want to read data on pins of port A, okay, we should configure all the pins or the pins that we want to read data of them as input. You see that here for reading data of all of the pins of port A, at first we configured all of the pins as input by writing 0 for all of them. And then we started to write X is equal pin A, meaning that read data on pins, and again return 0 semicolon, and the curly braces is enclosed. Another code, int main void, curly braces open and enclosed. DDRA is equal 0B 8 zeros. All of the pins or bits of port A are set to be as input. Then port A is equal 0B11111, 8 ones. What does it mean? It is related because the port pins are configured as input, then writing 1 for each of these pins means that the pull-up resistor is activated, and X is equal pin A. Because DDRA is set it as input, then we can read its data by using this code and return 0. Any question? Do you have any question? Actually, this session, we started to writing the code. And for writing the code, we said that we need to have input-output ports configuration. All of the codings will be based on these 3 registers: DDR register, port register, and pin register. and we should have sufficient information about duty of each of registers. Any question? When we want to activate pull-up resistor, okay, one of the questions have problem about the pull-up resistor. Actually, we use port A, port X resistor, or on the other hand, this is called data register. We said that there are three kind of registers, as you remember. One of them is port data register. For activating pull-up resistor, we use port data register. But for activating pull-up resistor, we need at first, as I explained here, to configure the bits of the port that we want to activate the pull-up resistor as an input. And for configuring the bits or all of the bits of port, we use DDR register. DDR register bits, or one of the bits that we want to pull up to activate its pull-up resistor should be written 0, meaning that it's configured. It should be configured as input, and by writing 1 for that register in port X register, then we can activate pull-up resistor. However, if we want to deactivate it, we can write 0 for the bits related to port X register. Any other question?
Hujam, can you tell us about the midterm?
Is there any schedule for your midterm in your program?
Yes, it's supposed to be at the 13th. 13 of
13 would be 10 is Monday. It would be Friday. Am I right? No, Thursday. It would be Thursday. Let me check the schedule.
Yes, Thursday.
Yes, it would be on Thursday. Which o'clock?
It's online.
3:30. One of the students, right?
Sorry, Hocam. There's some
Let me
confusion.
to check.
There's some confusion in the table. He said at
Thursday.
first microcontroller and
All of the
microprocessor.
schedule is related to Thursday.
Yeah, but the time is different.
Okay. Time is different.
There's two courses, microcontrollers, which is CENG318, and microprocessor.
Okay, I know, and microprocessors.
Are they different or they are the same?
Who is talking? Hamza, are you talking?
Yeah.
Okay. One of the students, right? 350.
Yeah.
Is starting from 350. However, today I'll ask from Gulseri Hoca, and I'll send email for all of the students. Yes, let me to talk with the director because the number of students is so high. If I want to have a midterm exam, I'll let you know today about its schedule, meaning that from OIS, I'll send you email. For all of the students, I will send email, and I will determine I will distinguish the schedule and time of the midterm exam. And if you don't want to have a midterm exam, only we will have a final. But final would be in terms of coding and writing code in Code Vision and simulating it in Proteus. Okay.
Hujam, one more thing.
Yes.
If we're gonna have a midterm, it's better if it's delayed by 1 or 2 days, because at Thursday I already have 2 midterms, including microcontrollers. We have 3.
No, I didn't change the time of that, the day of that. Only I will let you know about the time of the exam. Meaning that it would be in which o'clock.
Is it
I will
possible
not
to delay
change the.
it, to change the day or not?
No, of course, I'm sure that it wouldn't be possible, because you know that they determine the exams, midterm exam, as online. And next week only would be online, because you know that the universities is open right now, and all of the classes are face to face. And only next week, for 1 week, all of the classes would be as online, and because it is the midterm exams, and we don't have opportunity to change the time. In that case that you said, the midterm exam would be as face-to-face too, if we want to delay it. However, let's to talk with the director. Maybe I want to omit it, meaning that I don't give a midterm exam. I don't want to give a midterm exam, but at first I should talk with director, and then I decide the situation. Yes, Amina. Do you have any question?
Yes, I tried
Hello.
downloading the Code Vision and the approaches on my laptop, but it's not working. I sent you an email, but you didn't respond.
I think you're working with Macintosh. Am I right?
Yes.
Okay. I don't know how you can install it to Macintosh.
Okay, so
Because all of us working with Windows. Also, I have Mac laptop, but none of the applications related to electrical engineering and also computer engineering are work in Macintosh. You know that, and we are actually we have to install Windows to our laptop. It is not an engineering laptop. All of us know that. However, I'm using Apple. But I'm using also Windows in my Apple,
so I
because
should
I'm an engineer, and I should install Windows to have the different softwares in my laptop.
So if I install Windows to my laptop, it will also work.
Yes. For Windows, all of the applications and softwares are free.
Oh, okay. Thank you.
Okay. Thank you very much. Okay. Any other question? No question? For next week, however, after next week, please install the applications and softwares that I suggested, because we start to the coding, which is the interesting part related to this course. I will send you, if I wanted to decide to have midterm exam, I will send by email. I think it would be till the different types of till end of the different types of functions, meaning that today's first slide, it's including today material, but only first slide from first session to today. Any other question? Let me to decide about situation and I'll say you, okay? Mariam, I'll inform you about the situation. Okay, thank you very much and have a nice time. Thank you, bye-bye. Bye-bye.